Welcome, Shiny enthusiasts, to a first-of-a-kind Shiny gathering, where we are taking a spotlight on an open-source package. Today, we embark on a thrilling journey into the realms of Shiny applications with our open-source spotlight shining on the new telemetry tool that we released mid last year that is called the shiny.telemetry. I'm your host, Andre, and I'm here with Wlademir Prates, and I'm thrilled to have you join us for the first episode or for the first gathering of 2024. We will take a look at Shiny Gathering, an internal project at Appsilon that was released as an open source R package. In this gathering, we'll explore how to integrate Shiny telemetry and how it can revolutionize your Shiny projects by providing deep insights into user interactions, behaviors, and engagement. So get ready for hands-on expertise as Vlad and I engage in live coding, unveil practical tips, and sharing best practices for harnessing the full potential of user tracking in Shiny applications. Whether you are a seasoned Shiny developer or just diving into the world of R packages, this gathering, promises to be a treasure trove of knowledge and expertise. So buckle up and get ready for an exciting exploration of Shiny telemetry. Uh, let's embark on this adventure together. We welcome participation on this discussion, so feel free to ask questions, whether you have experience with the Shiny telemetry or not. And our hope is to have an interactive session, and we can sparkle some interesting debate, and that will not only help our users or reach out new users, but it will also bring new ideas for the future for this package. I don't know if Vlad, do you want to introduce yourself a bit before we start talking about
Yeah,
Shiny Gathering?
yeah, for sure. So I'm working as an R Shiny developer at Appsilon since December of 2021. So it's a pleasure to be here with you. And I've worked in some different projects in companies in pharmaceutical companies and also in other uh, areas. And so I hope that we can have a great interaction here.
Great. I'm also a Shiny developer at Appsilon, and I was one of the developers of this package. Vlad, he worked on implementing this on a project, so he'll give a fantastic insight on how that was. But to start off, I'm going to talk briefly about what is Shiny telemetry. It is a versatile tool for monitoring user engagement, and I'm going to start sharing my screen. All right. So as I said, it is a great tool to monitor user engagement and accessing the success of the rollouts, and basically to understand user behavior. Shiny telemetry tracks events occurring on a user session, such as input changes in the page or tabular switching, and all of the events that are going on. Or that can be tracked within a user session, even JavaScript events, and store them in a local or remote database. We'll get to that later. When integrating telemetry on a Shiny application, it will assist on data-driven decision-making and product development. This tool has the ability to provide comprehensive insight to create user-centric solutions. The key reason for creating this package is to understand our users and use that information to create better and beautiful applications as a result of that data and information. This application had a dream team working on it. Camille Zilla was one of the developers, Rekle Vibal, Christian Igres, and me. Christian took part on an initial prototype in 2019, and it was left in a dormant stage. Camille, Rekle, and I made a final push last year to refactor and release it. Sorry about that. Let's take a look at a real example. So as Veda said in the comments, live demos are usually problematic, but let's gamble. We'll start by looking at the blog post that was published earlier this year about shiny.telemetry, and it has well, a lot of information, but we're gonna scroll down and get to a simple example. This application is quite sorry. This application is quite simple, and although it already has some telemetry, I'm going to remove that and just run it first as a standalone Shiny application. It's just an if I move it here, it's just an histogram with an input box that, as you increase the number of the value here, the number of bins increases, or the number of observations increases. What telemetry allows us to do is to, with a minimal approach. So the code itself that we need to add to an application is very, very minimal. We can actually start to track what is happening on the application. So first, we start by defining a data storage. In this case, we are going to use the simplest example, or the simplest sort of storage device, which logs to a file. The only parameter is actually the path to that file. We then start a telemetry, instantiate a telemetry object by giving it a name and that data storage backend. Additionally, we should use, we need to call on this function, use telemetry, that will add some JavaScript to the UI definition. Next, the last step is to start a session within the server module. And with this 1, 2, 3, and 4 lines of code, we will integrate telemetry into that initial application. And although the initial application is very simple, it only has actually one input box, this intervention can scale to any other application. Once the session is started, it will monitor by default all of the inputs. It won't monitor the values as a default setting. We think that it's better to protect that sort of information. But it will register the input changes here. It will also register the browser that the user is using, and whether if that user is connected to a session. Currently, we support POSIT Connect. So if you have if you have this application deployed to a POSIT Connect instance, and your user is logged in, it will capture that username. It also supports Shiny applications in .io, where it requires a simple tweak. So we are just looking at an application that most of us already seen many times. But if we go back to our console and we go and inspect that log file that was created, it has a bunch of information. The data itself on the log file, it is stored as individual lines in a JSON format. So every individual line is a JSON format string. This sort of storage depends from data storage, but in the log file, it looks like this. And we can see, well, we can actually see a lot of things. So let's go and back to the example. And let's read this. Let's read this log file. The R file is stored not in in the root folder of the project. So I need to do this little trick, data storage. And now I'm going to read the event data that was going on. So a lot of things happen. This file itself, it has a lot of different sessions already. So I'm going to do one small additional trick with this, just to delete it, run the application again. Let's increase the number. Let's go out. And let's read the data storage device. All right. The data storage, what telemetry actually tracked. So we can see that the first line is a login row, where it has no username because it is not deployed in a way that it can capture the username. But we can see the information about the browser. So we can see that it was run in Chrome, and the different inputs events that were being tracked. We can see that n was changed. Let's see, it's around 12 times, 11 times. Sorry. But there is no value to it. So we can, in the value, you can see an A field. If we go back to the...
Can I ask a question here, Andre?
Sure,
if you could go back to the data, just trying to understand, for example, if considering the scenario where we have the username, okay? So if I'm not wrong, just confirming this information, the username would appear in the first row, I guess, but in the login, but not, and possibly in the logout that you generated after closing the application, but not in all the rows. Am I correct? So we could identify that it's related to that username based on the session column. Am I correct?
Yes, exactly. The session
Okay.
it generates a unique unique ID for each session, and the username can be tracked via that session in the login row. Yeah, thanks for putting that out. The data itself, it also has the timestamp for the action or for the event and when it occurred. So I was going back to the initial example, and in one of the parameters of the start session, this is where telemetry is actually triggered and starts to listening to all of the events. We have a bunch of options, and one of them is to track values. By default, this is set to false, as I've said, just to prevent. I guess for privacy reasons, we prefer so that the default parameter is false. But if we set this to true and run it again, let's change this to 20. And if we go back out of the application and we go again, we can see that there was a new session that started with a different session ID. Again, on the same browser, and there is an initial input called or initial event value for event ID for n, and the change that happened is now recorded not as an NA, but as the actual value of it. And this is sort of a minimal example. We can look at this as we can the design choices of telemetry is for this to be the less intrusive as possible. So so we can integrate easily in existing Shiny applications just by adding a few lines of code. Of course, sometimes you might not want to use a file for that, a log file that is stored in the server. So, but Shiny telemetry also allows for different data sources that we'll talk about in a few minutes. So, moving on from this simple example from the blog, we actually can open. Let me start to close close some tabs. And we can look at some examples that come with the package. Again, we have two different applications, one from called instrumentation, which is the actual Shiny application that is now that tracks now the events. And with this application, we have a bit more of a complex application where there's again the same number, um, the same application as we saw before, but now a bit more stylized with Shiny Fluent. And every time, and this event will be tracked as well as other events in this application. Let's say we change tabs from home to another tab. We click here many times, we change to yet another tab, and we go back to home. Let me close the tab, and let's take a look at the default dashboard that is being that accompanies this example. We open app.r, and we are going to run the app. Let me open it in the browser. And we have here a dashboard that will help, at least for an initial analysis, it will help us to understand what happened in the session and what information can we get with Shiny telemetry. We can get the number of unique users, the number of anonymous users, the sessions that were open, and the average time spent on an application. This alone is quite useful because we can understand if if users are just logging in and logging out, or if they are or how long they are staying on the application. If we go to the activity, so what was actually happening there, we can see here on today that there were 14 events that where input was changed, and 12 events where navigation was changed. And we can actually drill down onto this information and look more specific in what happened. So we have this input ID that is used to track uh, the navigation on that Shiny application. And if we go, we can actually see how many times each tab was clicked or was navigated to. 2 for another widgets, 6 times for the home page, and 4 times to the widgets. This sort of information is quite high level. So if you want to create your own analysis and customize personalized analysis, you can always use the data itself, read it, and process it in a way that you want to know or that you like. You can, for instance, see from the home page what is the first tab that the user allows you to click. It cannot be this information cannot be reviewed on this dashboard, but you can create your own analysis that looks for this sequential type of information. If we look at instead of being a navigation, the input, we can actually see the buttons that were clicked. So first of all, the bins. So 12 was clicked, or 12 was selected once, 15 was selected also once, and so on. The apply slider button was clicked 3 times, and the other button where it said "click me," it was clicked 7 times. And we can actually this sort of information allows us to understand the behavior that or what users are doing within a session. For the user-specific stats, this information is not very. There is not a lot of information here because it was a single user that single anonymous users that interacted with the Shiny application. But over time, you can get to understand a bit more about the patterns of your users. And with Shiny applications, especially those that have have a logged-in user, it will help to understand how specific users are using it, or how a group of users are interacting with it. it will also allow us to track the session times, as I've said. And with this, we can going back to the example app that that was being tracked. We can again see that the implementation is very it's very simple in terms of Shiny telemetry. We have here a Shiny application with a UI that is being defined, where use telemetry is the call to add the JavaScript, some JavaScript specific tasks that happen in the background. We initiate the telemetry here with the data store with a log file as a data storage backend with a specific path, and then oh, then we have a start session. Here we are tracking users and we are supplying information about the navigation. So which input ID is being used to navigate? In this case, it is UI sidebar. Otherwise, there is nothing else here. There is this if, but this is for a deployed example that we have that really helps to have it here on an example that is deployed to RS Connect. That I'll get back to later on to check out the user ID, but now I'll ask Vlad that you've implemented this on a project, and do you care to share a bit about your thoughts and your experience doing this? What kind of questions you had, and how was the experience?
Yeah, sure. Thank you, Andre. So yeah, I can start with the context. So I was working in a project, and then we had some Shiny apps with the client, and we had already implemented user metrics. That is another application that helps us to understand how many sessions we have for each application, but we don't know the details, like, for example, how the users are using the app. So this was the question that came from the client. If we had some kind of tool that could help them to understand how the users were using the app, and we started with one application that had, for example, several charts and several inputs, and so they'd like to understand if maybe one chart or one section of the application one was not necessary, and we should maybe focus in other ones. So this was the context, and so we decided to implement Shiny telemetry, and yeah, especially to track specific inputs from the Shiny app. And about the experience implementing the Shiny telemetry, and the strategy was that, first of all, you see that Andrea has shared that by default, Shiny telemetry is tracking all the inputs in the application, but you can imagine that in a larger application, it's confusing to track everything, all the inputs. We usually don't want to track everything. So we started mapping with the client which were the inputs that they would like to track. So this was the first work that was done, and we created a table, like a dictionary, like a map, showing to us in which inputs we should focus. Yeah, and we also mapped the input IDs, and this process also, it was also good for the, let's say, the quality of the code, because it required from us as developers to improve the names of the inputs. So there were some inputs that was like with some random names or things like that, and it was just for the developers to understand, and this process made us to improve the names of the inputs. And also In technical terms, okay, this is good. In technical terms, what we are doing, so we set this parameter. I'll share the screen in some minutes, but we set this parameter to track all the inputs to false. So we were not tracking everything. And then what you need to do is to go input by input and say to telemetry that you want to track that input. And so in technical terms, we had that application with several modules, and we are in the main file. Actually, I can share this process. I can share my screen. I can share a quick example here. I think it's better to visualize. Sorry for this mirror. So yeah, this is just one example. So please don't try to understand the whole application here. I just want to share that in the main file of the application, we had started the telemetry with the track inputs parameter to false. And then when we go through the modules, for example, in every module, we were passing telemetry class as
Well, can you zoom in a
parameter.
bit because
Okay.
is good. Just a bit.
Let me see, just a second. Maybe it's better now.
Yeah.
Okay, so yeah, what I was saying is that here I'm just starting telemetry with the track inputs set as false. Then the decision was to pass the class to each module as a parameter. And so if we go through the modules, we always see telemetry there as a parameter. And for example, in this case, this is the end module that was where we want to track the inputs. And so we implemented this short code in all the modules where we had some inputs that we would like to track. So for example, here I was applying telemetry log input function to these specific inputs for these specific modules. And we are doing it also for the other modules. So this is just an example of how we decided to implement telemetry in this business case. And yeah, in terms of the
Just to
implementation for
clarify
this,
something,
yeah,
if I can
sure.
interrupt. So you did this because otherwise it was just too much information, right?
Yeah, I think it was just a strategy to have everything inside the module. So yeah, and
There's
for
another.
example, if then
Go
if
ahead.
your question is about this parameter, so yes, if we had it as true, we had a lot of information because the application was huge, and it was confusing to see everything in the dashboard to see that you showed with the inputs.
Yeah, because some widgets they even track, for instance, the mouse as it is moving on top of those widgets. So it might trigger a lot of input changes that you wouldn't want to actually look at and just create noise in the data or it creates a lot of information in there. Okay.
Yeah,
Cool. It is
just
a cool a cool way of handling this, and it also maps well together to maps well with something that we are planning on doing with shiny telemetry. Is that it is also to like tracking everything has a performance. It also creates a performance problem, as the server is writing that all of that information and sending it to the respective
Yeah.
data storage. This is something that we hope to track to handle in the near future by creating a queue system that will sort of group together a bunch of writes and flush those to the database that the underlying database. So it was
Yeah.
cool that you guys implemented this on this project, and I just wanted to like focus on that. But go ahead, keep going.
No, yeah. Basically, I finished about the thing about, and this is just a cool code that helped us to track just what we needed. But then we faced. I remember that we faced an issue, but I think it was one thing specific to the server. So I was not being able to deploy the main Shiny app after implementing telemetry with MariaDB. But the solution was to install one missing dependency on the server, which is Unix ODBC dev. So it was the only issue, because in terms of the telemetry implementation, it was very easy. We were able to implement it like in 3 or 4 days for a big application. So it was really nice, and the client saw the value, because with this function that analytics app that comes from the telemetry, can also build that dashboard that Andrea was sharing. But there was some ideas for improvement, because there was another, after implementing shiny telemetry. So in this context, we were using MariaDB to store the logs, and we are using POSIT infrastructure. So the users had account there in POSIT, and they were logged when using the app. But some of the users were not logged in, and it caused one situation where all the users that were not logged in, they were considered as one thing. So they were, we couldn't distinguish them. And here the client asked us if there was some workaround, some way to implement something that would allow us to distinguish those users that were not logged in the POSIT infrastructure. And so it took us some time to research, and we didn't have a chance to implement this solution in this client specifically. But I'd like to share with you that we managed to apply a cookies based approach to help us to have like a proxy of the user. And this is also in our blog post that Andrea was sharing. And so in the end of the post, there is this title here about extending telemetry with cookies. And this raised from this question from the client about how can we distinguish those not logged users. And I want to show you I have already implemented this code in my RStudio. I just like to quickly share it with you. So, and I just have one screen here, and so if there is some question, please, and I can help because I can't see the chat right now. So, if you see that first application that is also in the blog that Andrea was running, basically I will run this application, but with some extra code for this cookies part. But I will still have the same plot and basically the same UI. So what I want to show you now, and this part in the top was added to download the JS library for cookies, and here I'm just calling some JS functions that I will use in the app, and the rest of the app continues basically the same structure of that simple application that you have in the blog. Let me show you first what is happening here, then I think it facilitates to visualize. So it's the same thing that Andrea was sharing. The difference is that here I'm printing the cookies, actually the user ID that we create to act like a proxy for the user. So this is what is happening here. And what I want to show you, okay, let's go to the code. So basically I'm adding the JS code, the functions here, applying telemetry, and I still have only one input. If we have time, I'd like to show adding one more input, how it will look like. And then here I have a reactive that is creating like this proxy for the user ID. So it is like it's a bit there are some small differences comparing if the example that is in the blog post. For example, this I'm not using the same function to generate the random user ID here, but it's just a small thing. And so this part is creating that proxy that is the value that you see that is being printed. So here you see that I'm rendering this cookies ID, and this is the, let me find it. Oh, sorry. Yeah, this is the number that you see here. So let's make a, and just one last thing about this cookies implementation. So in this case specifically, I have here in the left side, I have the dashboard that Andrea was showing to us. So basically it's running with this analytics app function that comes from the shiny.telemetry. And the structure is that this app.r is in the this app analytics folder, and the main app is in the app in the root. So you can have an idea how you can have two separate applications. So in a production environment, they want to be in the same folder. Probably they could be like in different repositories. But yeah, just showing you the example. So let's try to play a bit with the application, and you see that this is the user that was created, so AOG, and I am like playing with the input. And so if you go to the analytics app, so now
Yeah, and it was funny that or not funny, but it is intended. No matter how many times you ran the application, it was always the same user ID that was showing. So this, as you
yes,
said, this is stored in the cookie on the browser, and it's reused. Every time that that same user will log into the application, as long as he doesn't delete as long as they don't delete the cookie.
yeah, and there is also so yeah, thanks for this point. And then so here you can see that for this AOG user, I was playing with some inputs in, so now and yeah, what Andrea said is a great point. There is also this expires value that you can change. So by default here in this code, it expires in half a day. So if you put 1, it's 1 day. So you can put like 7, and it will, the same cookie will expire in 7 days. So you can decide, because this is a proxy for sure. It's not exactly, it's not counting exactly how many distinct users, but I think that you all will agree that it's much better than if we had all the not logged users considered as only one thing. So Yes, I think that this is what I had prepared in terms of this uh, example about how we implemented it in telemetry in the client, and this this possibility to extend it with this cookies-based approach.
Very nice, very nice. And this application now is running on production with telemetry as of now, which is.
Yes.
Mhm. And I would like to pick up on that user and well, first of all, there were two questions on the chat. Kyle, he asked if that dashboard is provided within the package, and it is provided within the package as a general dashboard to analyze the data that telemetry generates. So you can always use that as a first step into analyzing the information and understanding what it actually tracks. And you can extend that dashboard, of course, or create your own dashboard or RMD report, or R script, a Python script, whatever, that will get the extra information that you need. There was a different question from Tuan as this looks quite neat. Thank you. And how does it compare to the Shiny Logs package? Well, it is a bit different. Shiny Logs approach is to track the events on the client side, so on the browser, and then send a message to Shiny that will then write to disk or to the database that supports. Uh, our approach is a bit different. Everything is mostly handled inside of the server, with the benefit that well, everything is running everything is running on the server, and we also support additional databases as backend storage. So we support MariaDB, we support my Microsoft SQL Server, um, Postgres, and that are not supported within that Shiny Logs package. And the new question by Tyler. If well, but just to finish about the Shiny Logs package, we do very similar things, just a different approach. Hopefully, we can learn from both packages about best practices, and hopefully, uh, get some very nice piece of software in both in both packages. Hopefully, like as I've said, our queue mechanism that we will work in the future, maybe it can also be integrated in the Shiny Logs. Shiny Logs. And uh, f- going for another question, that any known issues with using this package in Dockerized app? Uh, a question by Tyler Flockhart. And we there is no issue. It runs as is as any other Shiny application, and just as any other Shiny R package. So it actually our tests, they all run databases in Docker instances, the Docker containers. So the automated tests that we have that will test the backends. So Maria SQL, Postgres, Microsoft SQL Server, they all run inside of Docker containers. So there should not be any issue there. And the last question, at least for now, by Kyle, is that can we visit how to track this info in the if the app site is deployed on Shiny Apps or Posit Connect? And that's actually where I wanted to go next, and show like show something. We actually have the this is with the Shiny Connect instance. You can see here like something the dashboard, but I'm gonna take a risk and paste on the chat this instrumented app, and you can try open it and click it. Maybe it will crash, maybe it not will not. We'll see. But this application that we are seeing, it is exactly the same as the one that we showed before, and without any changes. It has that if clause, but that if clause will only detect if it's deployed in Connect. And I'll go back to it just so that we are sure. And it just uses a different data storage and taken from the configuration file. So in this data storage is it is a sort of a prototype data storage. Is a Plumber API. So what happens there is that the application will send instead of writing to disk, it will call this API, and that is secured, and it will write to it will then that the Plumber API will write to disk wherever it is deployed. It is also deployed in Connect on this instance. And this is required because every time we redeploy an application, the local files, they are removed. And this is something that we wanted to avoid, and to avoid by a server or by making it available different backends. That's why MariaDB and all those the databases storage backends are available. But the addition of this Plumber APIs backend storage, or the advantage of it is that it all stays in Connect, and you don't actually need any outside technology or outside deployment to have shiny telemetry working. And you don't have to set up a database. You just have to be careful to not redeploy the Plumber API there, and creating backups of that data, so that if any case the instance is redeployed or there's any problems, you don't lose the data. But this, as it is only a toy example, it serves very well. And well, that anyway, well, that is it. If we look at, let me open the analytics app. We can see a bit, that there is a lot of more information now from this deployed application. There is one unique user, and if we go to see who that is, it is me. So, and you can see that I've logged in with to connect, and it shiny.telemetry detects automatically which user it is. We have a bunch of other anonymous users. Here we do not have implemented the trick that Vlad demonstrated before, but we can see about the activity, what happened across time, and see. Let's take a look at which pages were opened. And we can see that another widgets tab was opened 10 times, the home dashboard 23 times, probably 23 different users. And when they opened the dashboard, and widgets 11 times. And here we have a much more richer information, as there are more users that are logged in, and they have spent an average of 6 minutes on the application. With the Shiny, let's open Shiny telemetry again. Let's go here. And we actually have a pull request from late last year where, so Shiny applications. I'll end this briefly, as we are closing into the hour and running out of time. Here's the variable. There was a pull request that added support, or that added support. It's not. It is an issue. I'm sorry about this, but for Shiny Proxy, and it added support to, when you start the session, you can get the environmental variable that Shiny Proxy defines, and use that as a username. So the username, it will be detected on each start of the session, and it will be retrieved from this environmental variable. I believe that Shiny applications.io does this also. So it's via environmental variable. So that may be the approach, at least for now, to get that user information. We do have some more things, some more demos that we wanted to take, but I guess we've took a lot of time on those. So we'll end the live coding part here. of this shiny gathering, and I would only like to talk about like a bit about the future of shiny telemetry, and I will be open. If you have any more questions, please place it in the chat. But regarding the future, we hope to continue to develop the shiny telemetry, implementing that queue mechanism that will address some of the performance aspects of shiny telemetry when writing multiple events when at the same time. It might get a performance hit, but as Vlad showed, this can be overcome right now by just looking at specific inputs and only actually writing and saving those that are really interesting for to analyze. We have a bunch of features that are being planned, and you can look at our issues to track and probably voice your opinion in about which ones are the most important ones. We hope to captivate the community, continue to captivate the community. There are already implementations of shiny telemetry outside of our projects within Appsilon. There was one that I would like to spotlight just before passing on to Vlad, where it was the support for the Microsoft SQL Server. It came from outside, from this user, Kappa and Graham West, and he created a new backend for shiny telemetry in a very simple way. He uh, he extended our R6 class. And, the way that we've set up, we haven't gone into the details of this, but the backend servers, data storage servers, they are quite extensible, or they are created in a way that you can create your own backend server to expand the functionality. Graham, he did that for Microsoft SQL, where he implemented the initialize function that in practice connects to the server, and then which in the connect function that really does this as a private method, and he didn't do anything else because this is a MySQL based data storage. So all of the logic, all of the queries, they're already created, and by inheriting from the class, you get all of those very easily. Exactly. So they are already created on this R6 class that Graham he bases his work upon, where the read data and the write data are already implemented in a way that he didn't actually have to do anything in this. He only needed to extend the or create his own custom connect function, which shows that this tool is open to input from our users and open to extension pull requests. I'll pass the word back to you, Vlad. And
Thank you, Andre. Yes, maybe I don't know if we have time for one last question, so please be quick writing it on the chat, and then if not, we are okay. The MySQL server connection is very exciting.
it
Nice.
is, it is. And this actually, if we go one last thing before we will actually stop. As I said, this is like this is works as a data storage backends. They extend from a principal a main class, and that only has a few methods that you need to initialize or you need to implement. The initialize method and the private methods that are the close connection, the write, and the read. So extending this to new the sort of data storage devices, it is quite easy for an experienced R user, and it is a good challenge for a more novice R user. But it allows to get some more input and to grow this package from the community. And,
Okay, so yeah, so as we bring our session to a close, I want to extend my deepest gratitude to everyone who joined us today for open source spotlight navigating Shiny telemetry for user tracking in Shiny apps. Today we've delved deep into the world of Shiny telemetry, exploring its capabilities, its development journey, and its practical applications. From our insightful overview by André to the real-world implementation experience shared by me, we've navigated a diverse array of topics. Our live coding sessions showcased the dynamic combination of Shiny telemetry with innovative solutions like cookie-based user tracking. We've also shown a spotlight on the future of telemetry in Shiny apps, discussing upcoming features, bug fixes, and yeah, that's it, I think. A special thanks to André, Verissimo, Camille Zilla, Christian Higras, and Rekle Vibal for their invaluable contributions to the Shiny telemetry project. But before we conclude, let me share one exciting update with you all. So don't forget to mark your calendars for the upcoming Shiny conference. You can check the shinyconf.com. The call for papers will be opening soon, presenting a fantastic opportunity for you to share your insights and connect with the vibrant Shiny community. So keep an eye on shinyconf.com for more details. So as we say goodbye, we encourage you to continue the conversation. Oh, on our Slack channel, do we have this Slack channel, Andrea? Sorry, is it? I'm not sure about this part.
I'm sorry?
Slack channel. I don't think that there is a Slack
There is
channel.
a Slack
There
channel
is, okay.
that will be added to the description when this
Sure,
video will
okay,
be
okay.
uploaded,
Yeah, so we encourage you to
where the
continue the
recording
conversation.
is uploaded.
Okay, on our Slack channel. And stay curious, stay connected, and above all, stay inspired. Until next time, thank you all for being a part of these Shine gatherings. Thank you. Oh, yeah. Call for papers is now open for ShineConf, so thanks, Jana.
Jonah, let's share the Slack channel for ShinyCon.
Okay.
Chat. Well, thank you everyone. Thanks,
Okay.
Vlad.
Thank you. See
And
you.
have a good
Bye-bye.
day.